Hello everyone, my name is Jared Cortez Benavides, and in this video presentation, I'm gonna go over frequency response measurements, and this is for my junior lab class with Dr. Laura Benitez, and this is being recorded on April 16, 2021. And in my presentation, I'm gonna be having the usual an introduction, a conclusion, and questions section. But here I'm gonna focus mainly on the procedure that I used to get my results. All right. Here it's just the introduction of what I'm gonna be talking about. As we can see on the first bullet point, an RC circuit it's a circuit network that's made up of resistors and capacitors. And in this case, it is not as complicated as a circuit as we would get in the real world. But for the purposes of the measurement techniques, this is good enough. Next, we have an op-amp circuit, which is basically a network that's made out of some resistors and an amplifier, which will determine the output voltage. Next, we're going to focus on different measurement techniques, which we're going to see which one's the best, which one's the fastest to do, and so on and so forth. And last, here we're going to determine the pole, which in this setting will be a point in where the the system significantly reduces the energy that passes through the system, and that's gonna be around -3 dB. For the first circuit that I did is a resistor capacitor circuit, as we can see on the simulation screenshot. Those are two resistors in series with a capacitor. As we can see, it's not as complicated as a circuit, but we are only focusing on the frequency response and not as much in the circuit itself. And here, as you can see at the bottom, I did a simulation from 1 Hz to 100 kilohertz. Next, I derived the transfer function from the circuit we just saw, which was this one, and here was the voltage out over the voltage that's input, which will create H of S. And I did this using techniques I learned in my signals and systems class, which come in very handy. Next, here are the graphs obtained from all the different methods we used. And in here, we can see a lot of information about the system. The first one on the top is the magnitude body diagram, and the first one is the one from MATLAB. MATLAB plots the function, and it can describe what the system is doing. However, it is not as intuitive to know what the pole is or like what the parameters are. At the bottom, we have a sketch I did from my transfer function, and in here I can get a sense or a notion of what's going on in the circuit. However, it is not as accurate as I want it to be, because like it only tells me so much about the system. Last, the one in the middle is the simulated one using LT Spice, and that one can tell me everything about the circuit. Next, we have the body diagrams for the phase. This is measured in degrees, and as we can see, this is the exact same case as before. The LT Spice simulated circuit in the middle gives us the most accurate graph. Up next, we're gonna discuss what the differences are between all these methods. So the first one is a straight line asymptomatic body plot, and this one is somewhat quick to use and to come up with, but it is not as precise as we want it to be. Next, we have the MATLAB one, which is a plotted body plot, and this one can only tell us so much about the circuit. And last, the simulated one is the best way to see everything that's going on in the circuit. Up next, we have the op-amp circuit, and this one is made out of a TL081 op-amp with two resistances, as we can see on the diagram. On the right, we have equation number 2, which is the equation to get the gain of the circuit, which will be 1 plus RF, which in this case is 33K, over R in, which will be 2.2K. These are the simulated graphs for the frequency response of the op-amp circuit. And as we can see, it goes from 44 dB all the way down to negative 180 dB. And it goes for the phase from 0 degrees all the way down to negative 360 degrees. Here, we can see that we got a low pass filter with a gain of 16, and it's a non-inverting circuit because the input was in the positive side of the amplifier with no resistors added into that node. As we can see, we can observe all the different parameters of the circuits, and we can easily see all that's going on here. We can see that in every time the phase starts at 0 and then it goes to a negative value, and the amplitude on both cases starts at some point and then it decreases, meaning that we both get low pass filters. In conclusion, we can say that simulations provide the most reliable results for all cases, and all body plots that were created can describe the overall behavior of the system. However, the simulated ones are the best. And the frequency response is nothing more than just observing and analyzing what the response is as the frequency changes. The references I used for this presentation are here displayed on the screen. And if you have any questions whatsoever, just don't hesitate and send me an email. Thank you so much and have a good night.